remember, I will go over it probably, again as we go through it like next week and for the exam kind of thing, right? Keep in mind that in terms of T and B cells, there's that specificity that it has to be there. So in order for the cytotoxic T cell to kill a virally infected cell, that virally infected cell has to display that specific epitope. Let's say you have this cytotoxic T cell right here, and we know this cell's already virally infected, but the epitopes that it displays on its MHC1 right here doesn't match. What happens? Well, this cytotoxic T cell then falls away. It never gets active, right? We hope that other cytotoxic T cells behind it will have then the receptor that recognizes the epitope. So what we have then is, number one, we talk about helper T cells, macrophages going to your lymph nodes. They've already just swallowed up all the virus. For helper T cells, the macrophage is then going to display all the epitopes on different MHC2 molecules. Then the helper T cells surround the macrophages, all trying to mix and match their receptors to the displayed epitope on MHC2. Now, this is different. This is different because our target cell has been infected now. Because it's been infected, it's going to display everything from that virus. All of the proteins from the virus will be displayed. Now, it's displayed on MHC1 receptors, which will be found on all nucleated cells. In an uninfected cell, MHC1 displays host proteins. But now, they've taken over our machinery. So the host proteins I'll make is actually viral proteins. When that happens, I'll have the actual viral epitopes being displayed instead of host proteins. There's that kind of differentiation, right? We don't call our host proteins epitopes because that's usually something foreign. Now we're displaying epitopes instead of host proteins. Perfect, right? Well, not perfect, because we don't want to be virally infected cell. But if you do have a virally infected cell, we need to kill it. And if it says, right, the worst thing that could happen is if you have a virally infected cell, and then is a very mild level of kind of infection where you're not producing a lot of the protein for the virus. What happens then? Well, if you're not producing a lot of viral protein, you might not display viral epitopes to the same numbers. When that happens, the cell stays alive and produces more and more of the virus. That's what we believe happens with HIV. HIV goes into this phase where people go, and there's a quiescent phase, where you think you've killed off all the virus, but there's a cluster of them still in some infected helper T cell that we can't measure because those helper T cells are quiet at that point. They're not active yet, right? So we think we killed off all the virus, but then 2-3 months later, the person starts getting sick, even though they shouldn't. They should have 0 viral load, but yet they start getting AIDS-related type of illnesses, fungal pneumonias, right? Some kind of sarcomas, right, in the mouth, you get the thrush, all of this happening that are what we call AIDS-related illnesses. So that does happen, and what happens with HIV is that there are clusters of viruses and virally affected cell that goes quiet. As it goes quiet, we can't measure it because we can't go into the bone marrow and measure the viral load there. We can't go into your spinal cord and measure the viral load there. We only measure it through the bloodstream. And in the bloodstream, there is no virus at that point. Right? Again, in terms of inhibition, we need to have tolerance, right? State of unresponsiveness of lymphocytes to a specific antigen. Most common is unresponsiveness to self-antigen. Most of us have some kind of tolerance to allergens. Allergens, right? Dust, pollen, peanut oil, peanut proteins, right? So those are all allergens. We should not have a response to that. But a lot of people are starting to get huge responses to those allergens, anaphylactic reactions as well to those. And it's due to this decreased state of tolerance that we get. Now, in terms of tolerance of lymphocytes, tolerance of lymphocytes means that our lymphocytes will not attack our cells. That's very important, because if your lymphocytes attack your cells, there's a lack of tolerance, and we have an autoimmune disease. So how do we prevent that? We have deletion of self-reactive lymphocytes, then prevent activation of lymphocytes that does encounter self-antigen. So number one, if we have a lymphocyte that recognizes our host epitope, and it recognizes something foreign, it gets killed, right? If it encounters it and starts to attack it, it gets killed. So that way we make sure that we don't have lymphocytes that recognizes something